Biochemistry, Chapter 13, Introduction to Metabolism. We need to keep in mind that when we're talking metabolism, there's multiple versions of metabolism out there on this great big planet Earth. We have numerous organisms that are what are referred to as autotrophic. These autotrophs utilize sunlight, capturing photonic energy, or they're taking thermal energy if there happen to be, a couple miles down in a thermal vent at the bottom of the ocean. They capture that energy and they use it to link together carbon dioxides. Whether the carbon dioxide is taken from the water, it's taken from the air, or maybe some other compound, depending upon which type of microbe you're talking about. But they do that work themselves. You counter this with organisms that are heterotrophs, like we are. We don't do any of this. We have to ingest. We take in organic compounds. That's where we get our energy. The energy in the carbon-carbon bonds, the energy in the excited electrons. Some are producers, some are consumers. When we look at, in this semester, when we look at metabolism, glycolysis, citric acid cycle, lipid synthesis, whatever, there are going to be a series of reactions that have to take place. It's no one and done enzyme does everything. It's going to be a series of small steps in a pathway. Each step is going to take a substrate, turn it into a product. That product, or metabolite, while it's a product for enzyme 1, well, enzyme 1's product is now the substrate for enzyme 2. Enzyme 2 product is the end substrate for enzyme 3, and so on and so forth. So we're going to be looking at not only the metabolites, the intermediary metabolism, this series of little events. We're also going to be looking at the enzymes that catalyze these reactions. Because when it comes down to it, as you're sitting there watching this video, every cell in your body has its own metabolism occurring. The making and the breaking of things. Stuff gets built up, stuff gets broke down. The catabolic is where you take in things. It's the reason you eat, the reason you drink things. You take in these organic compounds and through catabolic reactions, big things get broken down into little things. A protein gets broken down into polypeptides. The polypeptides get broken down into individual amino acids. Some of those amino acids will get broken down into, individual, as you see, well, if you look at the slide, it's behind my head, gets broken down into ammonia, carbon dioxide, individual molecules like that. Well, some of those amino acids, some of the sugars you eat, many of the things, the fatty acids and whatnot, will also then be taken and recombined in different ways. We refer to this as anabolic metabolism, anabolism, the synthesis, the making, the taking of these little precursor things and making new proteins, new DNA or nucleic acid molecules, the making of new lipids for new membranes and whatnot. One of the things if you've had me for Selimalek, that I've tried to just beat into all the students' head is, even though we see in textbooks, everything is, when we talk metabolism, glycolysis, the citric acid cycle, oxidative phosphorylation. It's always discussed in the terms of glucose. And unfortunately, students do walk away thinking glucose is it. Glucose is all. That's all there is. Nothing else matters. And when you look here at this figure, no. Everything you take in, you go and you sit down. For lunch, you have a cheeseburger, you have some French fries, or you have a salad, whatever. All the components of the cells that make up that food you ate can be broken down. The phospholipids that make up the membranes get broken down into individual fatty acids. Because remember, phospholipids, it's a glycerol and 2 fatty acid chains, a phosphate group, and maybe something above that. Break down those fatty acids. Those fatty acids get cut every 2. Get turned into acetyl-CoA that goes into the citric acid cycle. There you go. There's your energy. Or the acetyl-CoA gets used as a precursor to start building up to make new things. So, starch, glycogen, sucrose, phenylalanine, pyruvate, leucine, isoleucine. Hey, wait a minute. Serine, alanine, phenylalanine, those are amino acids. The amino acids get broken down into acid so that they look like acetate, which acetyl-CoA, which can be fed into the citric acid cycle. Some of those steps, that's what we're going to see in a later chapter. The intermediate steps that we see in here look exactly like, if not are, with a little twist and a tweak, amino acids themselves.